So hello and welcome to The Way to Be. I'm Frederick Dunn and I have a long one for you today. We're looking at an observation hive. In this video, a lot is going to happen. But we're starting off with listening to queens piping. That's right, queens plural, more than one in their cells piping inside this observation hive. You're going to hear that, and you're going to find out that there's a lot of segments to this. Therefore, if you just look down in the video description, I will give you timestamps based on behaviors that you're going to observe in this video, because this video is an hour and 12 minutes long. That's right. Sorry about that. But I decided I would tell a complete story here. So we're going to see what happens inside an observation hive. I've said it many times before that observation hives are basically swarm generators. There are 3 observation hives in this building, and they were all started different ways. One was with a swarm. Another one was started with 3 frames of brood, including a laying queen. That's the one we're looking at right now. The middle observation hive that we're not talking about today only had 2 frames of eggs, brood, and larvae. So this is the one that had the laying queen, and the reason it has my attention is because these queens are piping. Can you hear that? There are several queens. There's another one. And I'll try to turn the sound up a little bit so that you can hear them better. You're also listening to the natural sounds inside this observation hive. So their wings are flapping, some are fanning, others are not. So we're looking at a small face section here so that you can see some of the behaviors going on inside the hive while we're listening to them. And we can see how these workers spend their days and how other bees don't necessarily put in a day's work. We'll see those too. And the recording is made inside the hive. So it's recorded separate from the camera. That way I can turn it up or down. I hope you can hear that. If the device that you're watching this video on doesn't have good audio, maybe put your earbuds in or your headphones on and you'll hear much more clearly the queens piping. Now the reason this is important to the beekeeper is because when we hear queens piping, this can happen several days prior to their emergence from their queen cells. So what has to happen before they emerge? The queen that's currently in this colony, and we've seen her, she walks around. We see her on the surface sometimes, and yes, you're going to see her in this video too. And there's some aspects to this queen that have me concerned, and we'll talk about that when we see her. But for right now, what we're looking at on the comb here is a waggle dancer on the left. She's got pollen on her hind legs. Brought them in, bragging to the others about where that resource is so they can follow her waggle dance guidance and go out and find more. We also have the advantage here of looking through glass. That means we're looking at the undersides of the worker bees. If they had Varroa destructor mites attached to their undersides, which is a favorite location for Varroa, we could see them here. These bees groom a lot. I also want you to see that a lot of these cells are open, vacant, unused at the moment. That also should be a concern this time of year because we would expect to see eggs, open larvae, and of course capped pupa in a hive like this time of year. So the warning sign that the queen has stopped laying is the fact that we can't find any eggs anywhere. This hive holds 9 frames in groups of 3. So that means there are 4 sides of these frames that we cannot see. We can see this side of the hive, the other side, and another trigger that we normally would see is that they're finished. They've filled out all of the available frames, they've drawn out all the comb, and then they wouldn't have space to do more work. But that's not the situation here. As you can see, that's the top frame. They have new comb. The cells are empty. One of the reasons the cells are empty is because the workers have consumed all open honey in preparation for departing this hive. So we're traveling down the face of all three of the levels of this hive. And you'll hear some high-pitched beeps as well, and those come from workers. And now we're showing you the entire face frame here of the middle level. And you can see some bees are fanning to ventilate, like those over to the right, and that's because they channel airflow up through the hive, up one side and down the other, although it's not necessarily very hot today. Not only that, we have storms coming in. We have bad weather ahead. That's why what's about to happen in this video was so unexpected. But if you look over the surface of the frame here, you'll see that there's capped pupa. To the right, larger cells, those are drone cells. And on the left, we have smaller sized cells, which are the workers. I'm going to let you look at this for a minute and just listen to the sounds of the piping queens. Now we're getting a close-up here, right dead center. See that oversized, super fuzzy bee? That's a drone, attaching itself with its underbelly showing next to us, but it's a great opportunity to make a comparison because he's shoulder to shoulder with a worker bee. You can see the difference in their sizes, the difference in their mandibles even, and their abdomens, and how much hair there is on it. Now, since we are in a brood frame that has drone cells on it, this may be a freshly emerged drone. Drones are male bees, and there's another one that we can see from the backside here. You can see how large their eyes are. And you can also see some behavior that we call washboarding, but the bees are doing it independently. Washboarding usually is a bunch of bees all in a row, usually on the landing board or near the entrance, but here we are up inside the hive. And on the left there, you see them working with their mandibles on the surface of the interior of the glass, and they're twitching their front feet, their forelimbs, over the surface of the glass the same way they do at the entrance. This is why I think, and again, to the right there, you see others washboarding on that surface. I don't think that it's a method for them to call in foragers from the field at the entrance. There's the queen, dead center there, and this is why I'm worried about her. Her abdomen looks large. She looks healthy, but if you notice the wings there as she travels, and I track her with the camera, her right wing is damaged. And I also want you to pay careful attention to the length of the wing on the right. It's been chewed by the bees themselves. This is not a clipped wing on a queen as part of an identification process, which some people do. But this queen has been spotted before with perfect wings. So that means the bees themselves, while they're trying to route her around and get her to get prepared to depart the hive, they've actually chewed on her and abused her a little bit. And we're going to see a little more of that. But this shows us that the queen is scooting around and she is not pausing to lay eggs. So she's making preparations to leave. They exercise the queen more. They still feed her. They just don't feed her as much. And we lost her there. There she goes again. and she disappeared under the frame. And in the meantime, we can listen to the other queens piping even louder inside their cells. They make that noise by vibrating their flight muscles without flapping their wings. Some worker bees can also create a beeping sound, and that's the high-pitched, just a steady ee, and you'll hear that periodically, and those are worker bees. They beep each other for various reasons. And here's a waggle dance going on again with a pollen forager. And those that are paying attention to that waggle dancer are other foragers that will use the information she conveys, and they'll head out and find the same resource if they decide it's something that they want and need inside the hive. Nectar is taken by the bees that are inside the hive and transferred to the cells. So outside bees do not get to come in and deliver their cargo, the nectar, into the cells themselves, but when it comes to pollen, they do come in and scratch off the pollen from their hind legs and put that in the cells themselves. They also mix pollen, so pollen from a variety of sources can be found in the exact same cell. And then the nurse bees amend that with nectar and honey, and it causes fermentation of the pollen, and it turns into what we call bee bread, which then the nurse bees will consume and feed back. But here on the top right, I want you to notice there's another one doing the grooming of the surfaces. The washboarding, only individually. See the forelimbs, their mandibles, their tongues are tucked back, and they're just lightly scraping the surface with their mandibles, and that keeps the interior glass of this observation hive clear so we can see through it and do what we're doing right now, which is make a video. You'll also notice there's a lot of unemployed bees here. They're sitting very still, they're conserving their energy. Honeybees are conservationists when it comes to energy, and they don't move around unless they really have a reason to do it. You will sometimes see bees going through, even during this video. They'll be grabbing other bees and vibrating them. I call those cheerleader bees. And they have their own reasons for doing that. Maybe they're activating a forager that's been dormant for a while. They sleep in shifts. They sleep in small periods of time. The older the bee, the more frequent the naps, the longer the naps. Younger bees nap less often and for shorter durations. You see bees that have their abdomens sticking out from those cells, and they're in there feeding and attending to open larvae. But remember, what's missing are the eggs. So when you're doing your inspections of your hives and you find that there are no eggs, and you don't see your queen pausing and laying eggs, you should maybe make preparations for that colony swarming. That is a nice, loud queen piping sequence right there. Now we've got some grooming going on. Just off center from the left there, you've got a worker that's grooming another worker, and they really are aggressive about it. Someone asked me if they groom all over, including the underside of the bees. They absolutely do. And often the bees that are getting groomed will submit to that, and they'll even spread their wings apart to give the groomers better access to their bodies. There you go, the right wing extended off there. And they don't miss a micro inch of that bee when it's getting groomed. And notice how that bee willfully holds her right wing out and then later folds it back when the grooming's over. So these bees are very active when it comes to grooming. They do that on the landing board sometimes, they do it inside the entrance, and they can do it at any other location inside the hive, although there do appear to be portions of specific frames where a lot of grooming happens. But anytime they suspect that a bee has something on them, they go into a grooming mode. And I do notice too that the workers that do the grooming do grooming more than others. In other words, I don't see a worker groom a bee and then go off and do some other task. They groom one bee, then they move over, start grooming another one. There's grooming going on at the 10 o'clock position over there, just light grooming. And of course we have those bees moving their forelimbs really fast on the surface and using their mandibles to scrape the interior surface. And again, it's like deck washing, but they're doing it more independently here, where on the landing board you see them in large groups moving together, forward and back, and grooming entire areas together. We're looking at the space between two frames here, top and bottom, and the reason I'm focused on this area is just inside, between the second frame and the face frame here, there are at least 2 queen cells. The problem is, the workers are in the way, we can't see them, but that's how I noticed it in the beginning. And then hearing this piping closed out that speculation. And even after they emerge from the queen cell, they can continue to pipe, and those that are still in their cells may respond with their piping sequences, which helps the newly emerged queen track down competitors, chew open the side of their queen cell, and sting them. Now you might say, Fred, why don't you open it up, find the queen cells, get rid of them, and keep the queen you have? Well, I like to let them do what they want to do. When it comes to getting rid of their queen, they have their own reasons probably for doing that. Reasons that you and I don't know. But the other thing is, remember, they physically have damaged their queen. They chewed her wings. They're running her around. They're not letting her lay eggs. So, for example, if I went in and squashed all the queen cells, then I might end up queenless because they could push her out anyway. So I just let nature take its course here. Now, of course, my plan is, when I said make preparations when you find out that your colony may be getting ready to swarm, by preparations here, I mean getting ready to collect the swarm. Kind of knowing where your bees tend to congregate, being aware of their activities. When they do swarm out, it usually happens from noon on, and that's going to be the case today. And then it gives us a chance to track them down. And the other thing is trying to get them to swarm to a branch that's accessible to us, that we can reach. But that's a whole nother topic. I've been very successful in getting bees to land on lower branches by zip tying pieces of queen mandibular synthetic pheromone. I can get a swarm from one branch to another that way. But that's another video. Today, we're listening to the audible communications, and we're looking at some of the waggling that's going on inside there to the left. Now we have one with pollen on her hind legs. Notice the other one is waggling with no pollen on her hind legs, so she may have found a nectar source. Sometimes they waggle even to show that there is a water source. Now, the number of waggle cycles they do, how long they remain on the dance floor and repeat this information, the higher the quality of the resources that they've found, and the more that bee believes in what she's bringing in, or the quantity is high. So if they just do a few waggle cycles and then they disappear from the dance floor and go off to scratch off those pollen packs from their hind legs and put them in the cells, they probably don't believe in that source much themselves, or there wasn't much out there. And this is another opportunity too, when we sometimes hear worker bees beep. There are storekeeper bees that when someone is doing a waggle dance, they headbutt them and give a quick beep, and they do it over and over, and they can actually shut down a dance. I haven't observed that myself, but that's a report from Thomas Seeley. So of course another trigger for swarming is the number of bees in the hive. So the more congested they are, number-wise, that's a trigger. It could be that they have gone honey-bound, which means all available cells are full of honey and capped and so on, but that is not the case with this hive. And another trigger is the beginning of a nectar flow, which is the circumstance here. Lower right, you see another waggle dance there. Pollen again, likely pollen and nectar. Sometimes when they're doing the dance, you'll see them pause and they'll pass on some of the nectar they've gathered through trophallaxis, which means the bee that's got the nectar in its honey crop will just open its mandibles, and the bee that wants to taste it will extend its tongue and take a sampling. Here we are right in the center. And remember the waggle directions. The waggle is longer, or there are more cycles to the waggle. If it's more complex, if the instructions are more detailed, if it's farther away, and their information is related to the position of the sun. And they'll go clockwise, then they'll make a turn counterclockwise, and then they'll do clockwise again, and then counterclockwise again. And there they are, trophallaxis. That waggle dancer is now passing on her resources to one of the foragers so they can taste what it is. That also helps them when they go to where they think the source is. They smell and taste and find the same resource that was brought in by that forager. Now her waggling's done, and she's headed off to get rid of her pollen. Now sometimes it can sound like one queen is louder than another, but what's really going on here is one queen in her cell is closer to the microphone. Now there have been instances where the worker bees themselves had selected their own queen that they wanted to hatch out to emerge from her queen cell, to the point where when the queen starts to chew herself out, some honeybees have been known to reseal the queen cell, preventing a particular queen from emerging from her cell. Meanwhile, they permit another queen to emerge from her cell. So they're making preferences even before the queens have emerged. And from egg to emergence of a queen from her cell is 14 days. Worker bees are from egg to an adult in 21 days. And of course, the bee that takes the longest and requires the most nutrition over the greatest amount of time there, as far as pupation goes, is the drone, 24 days. Here's the queen again, walking around. Little unsettled there. Now in the past, this queen has moved nice and slow across the face of the frames. She was laying regularly. Her patterns are good. So I saw no reason why they would supersede her. Sometimes they do that if a queen fails to perform. She looks healthy. She looks large. Her abdomen is fully extended, which everything about her identifies a queen that's productive. And there's a bee that stopped her to do a little grooming really quick. And there's another one that's feeding her. And those that feed the queen are the youngest. Her retinue, those are nurse bees that have early days in the hive. They've never been outside. So if you want to be in contact with the queen, you have to be fresh and clean and never have been a forager outside. Nice fuzzy drone there again, dead center. And remember, if these sequences are boring you or it's extending too long, please look in the video description and there'll be a timestamp to show you what happens when. Now at the top of the frame, slightly to the right, you'll see some grooming going on. That bee appears to be very young. It's fuzzy and its hairs are kind of silver, and it was trembling a lot, and sometimes they do that to get attention from the groomer bees, especially when it's never been outside. Also, when a forager comes in and trembles kind of in a sporadic way and continues to tremble all over the hive and seems to approach other workers, that can be a forager that's coming with nectar, and it needs one of the housekeeper bees, one of the storekeepers, to take its nectar from it. And if it gets no takers, it does that for a while and then just retires itself to a corner somewhere. Here we are again on the drone frames. Drone cells, and lower right there we've got one that's emerging. Doesn't seem like it's in too much of a hurry to get out. And you can see to the left there are some new bees in here that have kind of very light blonde hairs all over their eyes, all over their thorax. There's one moving along up to the left, and the more fuzz they have on them, the newer they tend to be. And of course that telltale light silver blonde color. Another reason that I know that they're not looking to invest in infrastructure is you don't see a lot of wax working going on. When we showed the upper frames where they have available space to expand, they were not making new comb. Here's a groomer again to the left at the 9 o'clock position. Very, very detailed grooming going on. And yes, if they find a destructor mite on the body of a fellow bee, they remove it. Trophallaxis is going on dead center, just at the 6 o'clock position. An older nurse bee feeding what looks to be a newly emerged worker. And this is the new wax at the top of the hive. You can see that the foundation is black, it's heavy waxed, and the surface of that foundation is very smooth. That's acorn heavy wax foundation. And again, they've stopped drawing out that comb. They're also not putting nectar in it, and they're not investing. That will all change soon when the next nectar flow comes in. But as I mentioned before, I think they're being conservative because things are about to change in this hive. I don't think they plan to stick around. Aside from the fact that we have all these newly emerging queens. More grooming of the surface there to the left. Forelimbs going, and the little mandibles just lightly scraping the surface of the glass. And the yellow things that you see, these bright yellow dots on the glass, that's where they've put little tabs of wax on there. But there really isn't enough space between the surface of the drawn comb and the surface of the glass for the bees to draw more comb. So they're just depositing wax, which, by the way, they can take off of there and reuse. So sometimes you'll see little collections, little globs of wax on the surface of the glass, only to come back in a few days and see that area clean and no wax on the glass. I also pay attention to their abdomens when that's up against the glass to see if there are wax flakes there. Now we're on a worker brood frame, and you can see the arc through the right hand side, almost like a rainbow. And they still have capped pupae. That's good, because if they swarm out, we're going to lose a lot of the workforce and we're going to need replacements. So these are worker brood. And of course, once they're in the pupa state, they don't require feeding anymore. They just have to be kept warm, and the temperature they're kept at is 94 to 97 degrees Fahrenheit. And you notice there's not a lot of fanning going on, and there's also not a lot of heat generating going on. When they're generating heat, they don't flap their wings, but they vibrate quite a bit, and there are what's known as heater bees. But I think they're at a pretty comfortable temperature here because they're all relaxed and they're not really trying hard to move air around. They can also heat cells by sticking their heads in, generating heat through the thorax, and heating all 6 adjacent cells if they happen to be full of larvae or pupa. So notice how calm they are now. Imagine coming in and inspecting your observation hive and finding them doing this. Now the word's out. It's time to go. All the bees in this observation hive are heading out the entrance. So there's a lot of chaos. It actually looks like every bee in this hive is going to leave. That's not the case, but every bee in the hive is definitely active and no one's taking a nap right now. And now we can clearly see the capped pupa that are still there. So those will be workers we need later. To the right, those are drones. Who cares? Top left, more worker brood capped. So this will be replacements. But that queen is going. Up here we have a second tier also with brood in it, and above that one we have the top 2, or the third one because there are only 3 high here, 9 deep frames total. The top tier has nothing but honey, but there again they've robbed themselves in preparation for starting a new colony somewhere else. So they've all filled their honey crops with honey, they've taken all the resources they can handle from this colony, and they're leaving. Now we say 50 to 70%, you know, those are averages. Any colony can do anything, really. But remember, one of the problems we have today is that we have stormy weather coming in, so why on earth would they depart? And the queens continue to pipe in their cells. They don't know what's going on. And here we are outside. Look at that sky. Now we're alive with bees, but the horizon's dark. There's clouds everywhere. Who's leaving? This is a question I get too. Do nurse bees leave? Well, nurse bees aren't the toughest bees in the hive. They're probably not very good at doing things that are necessary for starting a new colony. But foragers that have pollen on their hind legs are turning around and going right back out with the swarm. Drones are just along for the ride. They go anywhere the other bees are going. Lots of workers. We have a drone parked on the face of the entrance there. And I wanted to show you just what it looks like when you're looking at a hive that is swarming and departing. This is the kind of frenzied activity you see, and those that often fly out of the entrance are facing the hive and hovering around in front of it. And the question comes too often, which bees decide where they're going to bivouac, where they're going to land on a branch? Well, the foragers do that. The queen just follows the swarm of bees. In fact, the queen's not the first one out. The queen can change her mind and go right back in if she wanted to, but in this case, she needs to go because there are replacement queens soon to emerge, and they'll emerge within the next few days. You see the pollen on their legs? We have wax workers that go with them because they have to build new comb. Their crops are full. They can take on body weight about 30% more than their normal body weight. Those are averages again. I'm sure there's some bees that overdo it, that weigh themselves down. But the whole point is they know they have to start a new colony somewhere else, and that means wax building. You have to find a cavity. Now, they don't fly straight from the hive that they're departing and go directly into another hive or a cavity in a tree or some other suitable space. They find an intermediate location. Usually that's a fence post, it's a tree branch. Here in my apiary they use the same trees and the same branches over and over again, which makes it very easy to walk out in the apiary and see if we've had a swarm. Because let's be honest, if we weren't here looking at this hive when this happened, it happens in a very short amount of time, and we might not know that it occurred. So later on in this video, we're also going to show you what the interior of that observation hive looks like post-swarm, and see if you would have been able to tell the difference if you didn't look for secondary cues like the fact that there are no eggs and that they've also robbed themselves. Now, when they rob themselves, what I mean is they consumed open honey. They didn't uncap and tear things apart. Problem is, we've got heavy weather coming in, and these bees are leaving at a bad time. The weather report is bad. Micro storms, micro bursts, they were telling us. So why on earth are they going? Now, some people will wonder, how do they navigate? If they need to navigate by the sun, don't they need to see the rays of the sun? Don't they need ultraviolet beams cutting through the sun so they know how to orient themselves? Honeybees also navigate by landscape features. So they don't always have to see the sun or the ultraviolet polarized light coming through the clouds. Here's a drone I picked up, so you can get a close look. Look at those oversized eyes. He's along for the party. Now, which branch are they going to land on? Where will they collect? Hopefully someplace low and accessible. But there's a problem with this swarm. I think you already know what it is, if we've been paying attention since the beginning. So we have a little break in the weather here. And there they are, clustering on a branch. But I want you to look at the activity of this cluster. First of all, there are not very many bees here. Why is that? With so many bees leaving the hive, so many bees flying out to cluster on this branch. Well, if you pay attention to the cluster, they're animated. They're actively searching for something. And there are just as many bees joining this cluster as there are departing it. So the cluster size really isn't changing. It's not getting any bigger. Look at those on the surface that just fly off of it. You know what they're not finding? The queen. The queen's pheromone, known as queen mandibular pheromone, is carried by the workers, shared by the nurse bees through direct contact. They become the pheromone signalers regarding where the queen is located. Honeybees know when their queen is missing within 15 minutes. So we're kind of in the calm before the storm here, it seems, because there's no wind. Where's the heavy wind gusts? They told us were coming. The bees are quiet now. But between you and me, I don't think they picked a great day to head out. There's some blue sky up there. These are cosmos in the landscape, and the reason I show them, other than the fact that it looks cool against the stormy sky, is look how many of them have not blossomed yet. Cosmos provide nectar and pollen for the bees. We also have sunflowers here that you can see that are not yet open. So again, the big nectar flows ahead here. We're in the northeastern United States. There's some blue sky up there. Maybe the bees aren't that concerned about the weather situation. Look at the horizon. Could it be any darker? Now we're looking to the west, and that's the direction the storms are coming from, according to the weather people, and they know. Sunflowers provide pollen that can actually be medicinal to the hive. We also have goldenrod that's just getting started. The rain's welcome. We have a water deficit. Pond is low. The bees go to the pond to get their resources. We've also been putting out sea salt in their water for drinkers, and that's an option in addition to fresh water. 1 teaspoon per quart for those who want to try that out. Morton sea salt, highly recommended by bees based on their own selections. And they don't always take a lot of minerals and salts in their water, but this time of year it's in demand. It's a walnut tree there in the background. And we see a turkey vulture flying overhead there. And there's goldenrod. Lower left. There are a lot of varieties of goldenrod, and that's a heavy nectar flow. And asters will also join in providing for them. Maximilians are just starting to bloom. Now another thing, since heavy winds are coming, I want to walk through and make sure everything is strapped down tight. Laying's hive there. Langstroth hives here. By the way, I get questions about these stands. These are Lyson adjustable heavy metal stands. These are an iron T-post. If you have straps around all your hives, if they should by some chance blow over, you can just put them right back right side up. We have run out right after a rainstorm before and stood up hives, and the bees have been fine. Look at the rain coming down over there. I think we're going to get it. Now look at this cluster. Building up, getting larger. Nope. Staying the same. Searching for their queen. We know that the queen probably isn't in that cluster unless we had multiple queens in that observation hive. The queen that we saw had her right wings damaged, and therefore she couldn't fly. She wouldn't be on this tree branch at all. So what this is are the foragers and the workers inside this hive trying to dictate to the rest of them, including the queen, exactly where she would bivouac momentarily on this branch. And they need to cluster fast, and they need to tighten that cluster up because wind and rain is coming for sure. I'm sure bees know that. They know everything about weather. They always do the right thing at just the right time. And the reason I want you to see this cluster and the behavior on it is when you see a cluster acting like this, they're missing their queen. So what happens after so much time passes and they can't find their queen? Well, they just go back to the original hive that they came from. So it's another way, especially late in the year, when beekeepers that just don't want to lose the numbers from their hives. They want to restore those workers. There's a brood break no matter what because the queen's gone. But if you can get into a cluster of bees and you can find the queen and remove her, you'll see them returning to the hive just like these are doing. They gave up. The combination of the rain coming in, the storm, and the wind picking up And the fact that they can't find their queen means they're headed back to the hive. Yeah, that does not sound good. Now this was the beginning of a storm system, and overnight we have a storm counter that counted 168 lightning strikes within 10 miles. So you can see too that the foragers that are carrying pollen on their hind legs just join the swarm. But they've given up and they're coming back. Rain is starting to fall. So you may be wondering, why on earth am I standing outside with a storm coming, videoing honeybees? And if you notice, the bees are returning to other hives too. Look at the other entrances down the wall there. Why am I doing it? It could rain on me. I could get my camera wet. Doing it for you, so that you can see it. Maybe you don't have rain where you are right now. Watching rain coming down somewhere else could be therapeutic. Seeing what bees do when it starts to rain can be fascinating. Get out there with your umbrella. I'm not carrying an umbrella in this case. I've decided to just let the camera get wet. Look what's going on in the face of this entrance. If you look to the right, you'll see these bees sticking their abdomens in the air, and you'll see a light dot on the back of their abdomen. That is the Nasonov gland, and they're spreading the queen's pheromone because they're recalling those bees that just left to swarm. So it's the equivalent of a Navy ship hoisting its recall pennant and saying, "All hands return to the ship." Things are about to get bad wherever you are. And if you notice the landing board too, look at all those abdomens held high and that light dot, which normally is close up. Nasonov putting out their pheromone. That's going to anchor all those bees and get everyone back inside the hive before things really get bad. And they've got a lot to overcome because most of the bees are airborne, and they circle around the area in groups, and they smell pheromones and they find out where they're supposed to go. And of course they're looking for that intermediate cluster. The thing is, they're abandoning that tree branch right now. They're going to return without the queen. Because if she flew out, can she fly back? I don't think so. She has one set of good wings. Why is that called the Nasonov gland, by the way? Because a physicist named Nasonov discovered it. An anatomist, I'm sorry. He's not a physicist, an anatomist. Now look at the cluster that's on the face of that, and the sky has lost its contrast. Things are getting even worse around here. Some of the bees are just clustering to the wall. This is what's left of the cluster. Time to go. There's no queen here. Just go home. Now they got the message. There are no bees on this tree anymore. Although look at the ones that are still airborne, flying around. That's a spruce tree, by the way, for those who want to know. And look at that. Just after supper, come back outside. The rain has stopped. There's sun in the sky. And look at this cluster of bees. Why don't they move inside? Because they've already made their decision to leave. And they're staying out of the way. They're making preparations to go again. But there's a problem. Where's the queen? I almost stepped on her. She's right there with a tiny retinue of workers. Now, if you don't pick this queen up off the ground, if you don't provide her some way to seek shelter without flight, she's dead. If you left her out there overnight, a skunk would just come along and eat her. So I thought, who's going to waste their time on a queen that has chewed wings? I would. Why not? I've got boxes sitting around. We could start a nucleus. Now this queen, let's be honest, I would never use an injured queen like this to start a colony, really. But since we have surplus bees around, and it looked like they wanted to swarm and go with her, why not just set up a box here? I mean, she can't fly. She could walk. There she is. She's going to go up this blade of grass. It's going to pole vault over. And she's going to go right in the entrance of that 5-frame deep nucleus box. That's what we tell ourselves. I mean, we know. It's a perfect box. There are 5 frames of drawn comb in there. There's a tiny bit of honey in it. You know she's going to go in. Look, she's right near the front of the box. And then what does she do? She doesn't even care. Doesn't want to go in. It's like she doesn't want to save herself. So I could pick her up. Maybe I'll just show her the entrance and she'll go in. Look, right back out. Certainly these workers could just show her the way. It's one of the frustrating things about beekeeping. And of course, I know this takes a lot of time. There's people watching this going, you're just wasting your time. Look at those two feeding each other down there. I don't know from this distance who's feeding who, but that's trophallaxis again. One is providing a resource to another. The queen is not going in the box. She doesn't care. She seems to just be willing to end her life. And if she did, if she died, if a bird ate her, if the beekeeper stepped on her, these workers would just go back to the original hive, so why not just release them? Because I like underdog stories. I like it when I take a bee that appears doomed, or a tiny swarm at the end of the year that looks like they can't make it. I didn't buy this box just to do it, it's sitting around. It cost me nothing to put her in there. Look, there she is again, out in the grass, and I took the hive and I put it up on a hive stand. Because I thought, you know, if she does go in there, I don't want her to be on the ground. So let's pick it up. There she is, of course, avoiding the grass that I'm grabbing. And the reason I'm taking the grass with me is just in case it has her pheromone on it. Then the grass will smell right, and other bees will come. Get that queen. I didn't want to grab at her wings anymore. Her right wings are very truncated. They're damaged. They even chewed some of her left side wings. So I'm trying to carefully get her and, of course, encourage her to go into this box. Certainly she understands. This is her only chance for survival. If you grab a queen, never grab their abdomen. It can be easily damaged, so your goal is the thorax, which is right behind her head. Or pick her up by the wings if she has good ones. She's even beeping there. She's not happy. Can't imagine why. I mean, a couple hours ago it was raining out here. That means she spent her time in that rainstorm down in the grass with a tiny cluster of bees around her. And look at these faithful workers dedicated to their queen. They want to keep her clean. They're constantly checking her. They're feeding her. They're making sure that she's okay. Now the key is you have to get her inside this hive. Would you keep this queen? Or would you just end it right there? Here you can see even her left wings have been chewed and damaged a little bit. But all of her legs seem okay. Look at this worker down below opening its mandibles wide so the queen can stick her tongue out and get a drink. So they're making resources available to her. They want her to make it. And I thought I would sit out here and make this video and you would see the queen discover that there's an entrance and shelter. Did you see her tongue stick out right there? And then of course she'll walk right through that hole. She'll be fine. Life will be great. There's already comb in there. See that feeding going on? See her tongue? Trophallaxis. These workers are there for her. These are dedicated nurse bees that can care for her, that were just old enough to fly, strong enough to get out in the world. So she does some things that frustrate the onlooker. I have a lot of things to do. I have coffee to drink. It's getting later. Sun's going to set soon. She needs to get inside where she's safe. The grass that supposedly had her pheromone on it is parked over there on the left. None of them cared. Also, none of them are flashing their Nasanov glands and trying to draw in others. What are the chances that we can get the bees that are now clustered on the front of their hive entrance that they came from? What are the chances they're going to figure out that their queen is over here, 20 feet away from the building, facing southwest? The chances they're going to smell that pheromone and come over there and join this group? Slight, slim to none. They're not even trying. Alright, I got one. The one on the left is opening its Nasanov gland, but it's not flapping its wings yet. They have to fan it. Oh, look at the ones that are on the face of the hive. They are fanning, and they do have their abdomens curled up, and they are showing their Nasanov gland. Maybe we can get some bees over here before it gets too dark for them to fly. Because after dark, honeybees can't fly. Their vision's terrible. That's why they end up on the ground. That's why beekeepers that decide to check their hives at night end up with bees crawling all over them. Because when they can't see, they crawl. Or they fly to white light. Give the flashlight to somebody you don't like. Some of these forages are pretty old. Look at the edges of their wings. So it's a mixture, old and young. Look, here goes the queen. She's going to walk up the front. She's going to go straight in that entrance. It's going to be a perfect world. How old is this queen, by the way? Well, she made it through last winter. This was one of my resource nucleus hives that I overwintered with just 2 boxes and an insulated top and no food. They all made it except one last winter. So having nucleus resource hives like this one, these are nice thick wooden ones. I like the round entrance. They're deeps, so they take standard Langstroth deep frames. You collect the odd queens and tiny swarms and underdog collections of bees, and that tiny space gets managed very well by them. They build up and use them as resource hives for the rest of your apiary. And they surprise you at every turn, which demonstrates that that's a perfect interior space. 5 over 5. Now this year I've had to go 5 over 5 over 5, so I have 3 high in some cases, just depending on the population of the colony that's inside of them. This queen could not be more frustrating. Why don't they lead her somewhere? Why don't they grab her and drag her into that entrance? She's just tooling around. There she goes. She's going in for sure. She's very agile on her feet. And you would think she would go right in that entrance, but nope. Where do you think she ended up? Right on the ground again. Right in the grass. by herself, and now she needs everyone's help again. Enough of that. So what I did was, I put her in a queen clip. She walked right out of that, walked right out the entrance, onto the ground again. Would you give up? So the queen clip just had too big of an opening, so I put her back in the queen clip, closed it up, pulled a frame. Now I have 4 deep frames in here and a queen clip hanging in the middle of it, with the queen in it, so she can't get out. I made the decision for her. She was otherwise going to die, for sure. It's guaranteed. They're using their Nesnoff glands, but if you listen to the background sound, night insects are starting to chirp, the sun is setting, and their chances of getting a lot of bees in here to help them out are slim to none. Even the one on the landing board with her abdomen curled up, fanning away now, trying to get the message out to those that are still straggling in the area. Look at them. Just stuck on the face of that entrance, doing nothing. They don't even care. They're not going to come over and take care of the queen. They're not going to join the group. I'm going to have to help them out. So I'm going to take my nitrile gloved hand. By the way, for those who ask this question all the time, nitrile gloves do not protect you from stings. They can sting right through them. And I figured since I had picked up the queen with nitrile gloves, it might smell a little bit like her. Her pheromone might be there. These workers don't want to go inside. There must be a reason they're hanging out outside, and that's because I'm sure they want to join the queen in her tiny nucleus hive. So if I just put it in direct contact at the entrance, they'll smell her pheromone, and surely they'll go right in there and want to take care of the queen. Now her queen clip is at the forward part, so just above this entrance. And they go in. That's promising. So that showed that they were ready to defect from their original colony, that they're more than happy to join their queen. So rather than show you the tedious transfer of all these bees, I ultimately collected all the bees from the face of that entrance and transferred them to this hive, and they all walked in just as these are doing. So we end up with, 1,000 bees. We also had a little cluster of bees on a QMP pheromone strip down in the lower meadow that my wife wanted me to do something with them because they're orphaned bees. And we clipped that branch off, brought it over to this hive. They're not related to the queen at all. And wouldn't you know it, all of those bees also walked into this hive. So now we've got a couple thousand bees as of today inside that hive. So now this is a follow-up. This is today, August the 24th. Look at the entrance. They're stress relieved. Things are quiet. Look inside the hive. Would you know, looking at this, that this hive had a swarm? And the queens are still piping a little bit in here. Not as vigorous as before. Look how calm they are. You can hear neighbors mowing. Queens are still piping. But if you had not witnessed all this activity from the hive 2 days ago now, would you know that they had swarmed? This looks like a heavily populated hive. They're about to get some new queens. And the queens that have to emerge from those cells, not to mention the queen combat that's about to happen, where one will hopefully kill the others and leave them with one really good queen, she still has to fly out. We're a good 14 days out from having a queen that emerges, flies away, does her mating flights, comes back, and starts laying. Our insurance policy is right here. I know. She left the hive. She didn't seem to care about anything. They didn't like her. I mean, she had trolls in the community that were chewing away at her wings, and she was doomed if we didn't pick her up and put her in this. But what this will produce, hopefully, because now we have a couple thousand bees in here, don't forget, she'll produce eggs. And these eggs and resources will be available in the strange event that within a couple of weeks we don't see new eggs happening inside that observation hive. Now I've got a frame of eggs I could reintroduce. They would also be in decline because remember, they're not producing new eggs, new larvae, for the entire time that they don't have a laying queen. And we can, of course, reintroduce her if we wanted to. So that's what resource nucleus hives are for. Eggs, larvae, surplus queens, resources. I don't know what's wrong with that worker bee and why they decided that it doesn't get to be with them, but it's getting a working over that looks like very aggressive grooming, which is different than trying to sting it. Biting, chewing, and going over it like that is different from turning their abdomen into a little U and trying to insert a stinger. So there's a tight inspection service going on in this hive, and we're going to do follow-ups. That's hive number 15, the nucleus, underdog hive, and we have a lot of time ahead. And of course, what do I hear over here? Another hive is swarming August the 24th. That's not the end of the world. All the resources are the same. The other thing is, why are they swarming? Well, by the way, this has a hive gate on it. So those that want to know, do hive gates inhibit swarming? No, they do not. Plenty of bee activity going through this one. Now, they're leaving. The queen is leaving with them. This is a good size swarm. Good size hive, by the way. And again, it has a super on it. So it's got a deep, a medium, all full, and a super partially full. So they're not cramped for space. Their numbers are up. And again, the triggers are they must be making new queens. So if we inspect it, you would expect to find queen cells. And I'm putting you right in front of this so you can see what it looks like from the landing board. And when you watch your hives, and this is going on, there's a very good chance you're going to see the queen depart. And if this queen departs, I'm going to show you because you deserve to see her. There it is in slow motion. She's coming out. Right there she is. Healthy. Look at her wings. Perfect. Look at her abdomen fully extended. She's capable of flight. She's going to go right up the front of that metal panel, and then she's just going to take off. There she goes, joining the swarm. Now, I'm not going to take you through the whole drama of seeing this swarm land and then see them get hived and things like that. But this is not your fault. I guess the lesson I want to make here is bees reproduce as a superorganism. Their purpose is to gather resources, build their numbers, establish another colony. And their ability to do that is why we have so many honeybees around today in spite of all the challenges they have. So for the rest of this, you can just watch these bees fly out one by one. Guess what tree they went to? The exact same one the other bees were on. The spruce tree. Guess what I'm doing to make them accessible? I'm putting a queen mandibular pheromone, QMP, synthetic pheromone, lure with a zip tie on a low branch. What are they going to do? They're going to ultimately move to that low branch instead of 15 feet up in the tree. And then I'm going to go and collect these and put them in a hive box. For those of you who don't know what the hive gate is, by the way, it does a lot for the dynamics of the hive, but it also creates a long corridor that helps reduce and prevent robbing. It gives them a longer area to defend. But rather than explain all of that, there'll be a link in the video description if you want to learn more about what it is, where it was invented, and what the evaluations are looking like now. But I thought you would enjoy seeing this in slow motion, and all the bees are just scooting out of here. By the way, this is a big swarm. This swarm is so large on the tree branch that it looks like it would be a good 4 pounds. I know some people have had larger swarms than that. There's always something bigger somewhere else. But 4 pounds of bees is nothing to sneeze at, so I'm not going to just let these go. Here in the state of Pennsylvania, I've collected swarms as late as mid and the 3rd week of September, and still managed to get them through. The colony that's in jeopardy is actually the hive that they leave from at the end of September. They're the ones that have to produce replacement queens. They're the ones that have to have those queens fly out and get mated with drones at a time of year when the weather could go cold and stay cold. So the swarms, if we hive them with a laying queen, actually have a much better chance of survival late in the year than the colony they departed from, which is now queenless, and counting on their queens and queen cells emerging and getting successful mating flights at a time when birds and everything else, dragonflies, they are all hungry for anything that's on the wing. So, collect your swarms at the end of the year. Don't just let them go. If you've got hive equipment and it's empty, you have nothing to lose by putting bees in it. And, as I recommended before, nucleus hives. Put your swarms in those. This swarm is too big. It would fill easily. You would start them off with a 10-frame box. And 10 frames, by the way, 5/5, based on Dr. Tom Seeley's research, that is an optimal sized hive for a swarm to start in. So there they are. See what I mean? That's a lot of bees. Now what's different about these compared to the ones we started this with today? Look how calm they are. The queen is there. They've got one. She's good to go. So I want to thank you for watching this really long video. I hope you learned a thing or two and found it entertaining, and I invite you to subscribe to my channel. I'm Frederick Dunn, and this has been The Way to Bee. I wish you all the best with your bees wherever you are. Thanks for watching.